Today we're going to take a look at shifting quadratic functions and the basic geometric transformations that we did translating, which is shifting. In other words, moving the graph right, left, up, or down. And then we did some others. We reflected, we rotated, and we dilated in geometry. Today we're going to focus on shifting the quadratic function. So first of all, when we look at our first example here, this is the parent function, and by the way, I'm going to call this f of x. But I want to show you some points on this graph, which are 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. Parent function is the most basic of the quadratic functions. It is a U-shaped curve. And in the parent function, there is a definite pattern, which I'm going to talk about later on in the notes. But as we take a look here, 0, 0 is the vertex of our quadratic, also known as a parabola. Sometimes I use that vocab. But from the vertex, we move one space to the right and one up. And then from the vertex, we move 2 spaces to the right and 1, 2, 3, 4 up. We can also go the other direction. We can go 1 space to the left and 1 up, and 2 spaces to the left and 4 up. Again, we're always counting from the vertex. But as we take a look at our first problem here, it says create a graph of g of x that is 2 units up from the given graph for f of x. So let's start with the origin, and we're going to go up 2. And from this point, up 2. From this point, up 2. From this point, up 2. And up 2. Just like we did in geometry, we just counted to move it up. And hopefully your picture is better than mine. But what we are looking at here is we're going to compare. Oh, before we get there, we better put it in vertex form. Reminder that vertex form is y equals a times x minus h, quantity squared, plus k. Our vertex of our blue picture over here is 0, 2. So when we put this in, we're going to get y equals x minus 0 squared plus 2. And I am going to leave it in that format because then we can say, we can go from here to here. But when we look at the point 1, 1, here's our point 1, 1, and then we can compare it to our graph from g of x, which is my blue colored graph. What we see is 1, 1 became 1, 3. And what do we notice here? Well, what I notice is that my x values stayed the same, and the y values changed. On our next one here, it says create a graph of g of x. Well, we already did g, so let's call this h of x. And you can't see that very well. Let me try one more time. H of x. How about I do this? H of x. That is 2 units left from the given graph. So you want to go from the parent function, from the original ones, from the one that's already on your paper. And we're going to move all the points to left. So 1, 2. This point 1, 2. It lands right on a point on our parent function. Moving this left 2. Moving this original point left 2. And moving this point left 2. And here comes our picture. I'll call this h of x. And what we see from our green graph here that we just graphed, the 2 units left from the original graph, is that our vertex is -2, 0. And when we write that in vertex form, this is going to be y equals x minus a -2 squared plus 0. If we simplify that a little bit, it becomes y equals x plus 2 squared plus 0. Double negative is a positive. And then when we compare points here down on part D, our point -2, 4 on our parent function graph, -2, 4 right here, became, when we moved it to the left, -4, 4. And what do we notice here? Well, when we moved our graph left, what we see is that the x values changed. And the y values stayed the same. So hopefully that made sense to you with the illustrations, but here's a summary of what we just worked with. As a rule, we say that if we add something to our function, I'm going to call it c, we're moving our graph up. If we want to move our graph down, then what we're going to do is we're going to subtract some value. If we want to move our graph right or left, like above, we started with left. If you look back up here, what happens is when we came up with our function, this would be x plus our value. That moved our graph to the left. And here, then, it's going to go the opposite direction. This would be x minus c. It seems counterintuitive, but I didn't mess up. So we're going to flip over to page 43 or 44 in our packet here, and we're going to fill in our transformations rules chart. So I'm going to put those rules, which are a summary of these, on another video.